How to use FixtureBuilder 8.0 3D modular fixturing software. We're going to start by dragging and dropping the appropriate base plate from the catalogue. Next, I'm going to import the part that we're going to fixture. As you can see, it looks a bit like a large phone case. So the part isn't quite where we want it. To move it, I'm going to activate the triball. I do this by clicking on the triball icon on the part. I want to rotate the part, so I select the axis that I want to rotate around, then drag. I know I want to rotate the part by about 90 degrees, so I'm just going to type that in. Now I want the window on the other end, so I'm just going to right click and select reverse. By selecting the plane on the triball, I'm going to move the part to approximately the centre of the plate, whilst maintaining the same Z height. Okay, I'm happy with that position. I'm just going to make the model transparent, as I know it would be easier to construct the fixture if I can see the components under the part. Let's look in the catalogue to find the right fixturing components. First, I'm going to need some standoffs to support the part. As you can see, when you drag and drop components from the catalogue, they automatically snap to the base plate. I'm just going to raise the part a bit using the triball again so that I can see what's going on. I can move the part only in Z by selecting the Z axis, highlighted in yellow. Now I need to add some tips to the standoffs, so my workpiece doesn't get marked when it's fixtured. Again, these snap to the standoffs automatically. So now I'm going to constrain the part to the fixturing. To do this, I first select the part and then select Positioning Constraints from the menu. I'm going to use a parallel constraint to start with, as I want my part to be parallel to the base plate. Make sure this box is ticked so the part moves towards the fixture, not the fixture towards the part. I select the part and then the face of the base plate and then confirm the constraint. Next, I want to make sure the part is resting on the standoffs. For this, I'm going to need a tangent constraint. So I select the underside of the part, then the standoff, which snaps the part to the top of the fixture. In order to constrain the part further, we need to add more fixturing. So I've added two standoffs on one side and one on the other. I'm going to use some more tangent constraints to position the part in X and Y. To secure the part, we need to add some clamps. Browsing the catalogue, this one looks about right. I'll add another one of those on the other side. Okay, let's just change the transparency of the part so we can position the clamps correctly. We need to move the clamps to the correct position. To do this, we select Mechanism mode from the menu. This allows you to move components as you would in real life. I can click and drag the clamp to the correct location. The red flash you just saw was the software detecting a collision. Mechanism mode allows you to use collision detection, so in this case you can see when the clamps make contact with the part. Okay, I'm happy with that fixture. I'm going to generate some build instructions so I know how to put it together in real life. To do this, I'm going to select Build It from the menu. As you can see, the software has generated some assembly instructions, so I know where to put the fixturing components on the plate. Images and a bill of materials are also included in the assembly instructions. Finally, I might want to use my fixtured part assembly when I'm programming in my measurement software. I'm going to export the assembly by selecting Export to Measurement, and that's it. A complete fixture ready to use in measurement software. Thanks for watching this video about FixtureBuilder 3D modular fixturing software. For more information, visit www.renishaw.com/FixtureBuilder.